guys, welcome to programming screencast of 6 degrees of separation. So before going to the actual programming screencast, let us see some few prerequisites that is required. The first prerequisite that is required is you must know what is the graph data structure. By graph, I don't mean this kind of a graph which you would have been doing in your school physics, chemistry, something like that. You take some quantity on your x-axis and you take some quantity on your y-axis and you observe as you vary this quantity what is the variation in the other quantity. So such thing is what you call as a graph till your school days. This is not what we are going to say as a graph. We are going to say something like this, a set of few points and lines as graph. So basically graph is nothing but a group of some points and lines that lie between the points. That is what we call as a graph, and technically we call the points as nodes and lines as edges. This is the technical terminology. So to illustrate better, let me take an example. Let us consider the railway network of the city, of the country, railway network of the country. So the nodes or the points, let us get used to the terminologies nodes and edges. The nodes in this network is nothing but the cities or the stations, and the edges are laid if there is a direct train between the two cities. At least one direct train must be there, only then we will draw an edge. This is how we will construct this railway network. So between any two cities, if you take, there may be an edge or there may not be an edge. That depends on whether there is a direct train or not. So for example, see two cities, Chennai and Bengaluru. There is an edge between these two cities because there is some direct train between these two cities. Whereas if you see these two cities, Chennai and Guwahati or Guwahati and Bengaluru, there is no edge because there were no direct trains. And see, this graph is actually dynamic in real scenario because trains may be introduced every now and then, as well as a few trains may be not operated because of various reasons. So this graph keeps on changing. That is what I mean by dynamic. The edges may be newly added or deleted. Anything may happen. So this is just an example that there exists a direct train, then you will put an edge. If there is no direct train, you don't put an edge. That is how it is. And if there is an edge, you can say that I can reach from this node to this node. That is, from Chennai I can reach Bengaluru, and from Bengaluru I can reach Chennai. That is what is captured if there is an edge. But it doesn't mean that if there is no edge, we cannot reach this town. So let us see. See, there is no edge between Chennai and Guwahati, but still you can have another city in between, Kolkata, and you can reach Guwahati through Kolkata. That is, you take a train from Chennai to Kolkata, and from Kolkata you can take a train to Guwahati. So this is what you call as a path. So path is basically the way by which you can reach from one node to another. That is what we technically call as a path. So there is no edge between Chennai and Guwahati, but there exists a path. So it is not the case that if there is no edge, there is no path. There may be a path even if there is no direct edge. See, from Chennai you cannot directly reach Guwahati, but via Kolkata you can reach Guwahati. That is the meaning. And it is not all the case that there will be just one path. There may be multiple paths as well, as you could see here. So if there is a edge, you can say that you can definitely reach from this city to this city. And if there is no edge, that is not the case that there is no way to reach. There may be a way to reach even if there is no edge between the two cities. That is, you can have some city as an intermediate destination, intermediate point through which you can reach your desired destination. That is, from Chennai to Bangalore there is a direct edge, you can directly reach. From Chennai to Guwahati there is no edge, but still there is a path via Kolkata to reach Guwahati from Chennai, as well as from Guwahati to Chennai as well. The same path can be followed. And as you would see, most of the railway network is bidirectional. That is, you have trains in both the directions. If there is a train from Chennai to Bengaluru, there is obviously a train from Bengaluru to Chennai. That's how mostly it works. So that's why it is an undirected graph. We call it as undirected. That is, directions doesn't matter. From Chennai to Bengaluru or Bengaluru to Chennai, both paths exist. So this is what we call as an undirected graph. And we would always be interested in finding the shortest path. There may be multiple paths that may be present. Let me show you. See this graph? There may be multiple paths that may be present from Chennai to Guwahati. See, one path is Chennai to Kolkata, Kolkata to Guwahati. Other is Chennai to Bengaluru, Bengaluru to Kolkata, Kolkata to Guwahati. There are two paths in this smaller example. There may be multiple paths that may be present. In that case, when you have multiple options, we always go with the shortest path. By shortest, I mean the minimal number of switches of trains in this example. There may be some cases where we have something called a weighted graph, that is, the edges will be having weights. So basically, you can think of it as a distance between the two cities or the time the train takes to travel. You can consider anything as your weight. So that would be captured here as weight. So if for example Chennai to Bengaluru, let us say the distance is 400 kilometers, this edge would have a label 400. So something like that, the distances would be here as a weight, and we would like to find the one the path where the total weights, that is the sum of individual weights, is minimal. That is, if you sum up all the weights, Chennai to Bengaluru, Bengaluru to Kolkata, Kolkata to Guwahati, as well as Chennai to Kolkata, Kolkata to Guwahati, you will find the sum, and wherever the answer is minimal, you will take that path. That is what you call as a shortest path in a weighted graph. But here we don't consider weights. I just say the number of trains I need to switch. That in an undirected case, that is what I am considering here. In this case, the shortest path is from Chennai to Kolkata, Kolkata to Guwahati. Just I need to take 2 trains. But here if I take this path, then I have to take 3 trains. Chennai to Bengaluru, Bengaluru to Kolkata, Kolkata to Guwahati. So I'll have to take 3 trains. So this is not a shorter path in this scenario. The shortest path will be generally preferred. And whether there will be a path always between any 2 pair of nodes, that is the next question that is of our interest. And in some cases, there may exist a path between any pair of nodes you take, and some cases it may not exist. And in case if a graph is such that between any 2 nodes you take in the graph, there always exists at least one path, then you call it as a connected graph. See, if at least one path exists between any 2 nodes, then you call that graph as connected graph. So our railway network is almost a connected graph, because from any city in India you can reach to any other city. Although you may not have direct trains, you definitely have a path. That is mostly the as much as I know, the capital cities are mostly well connected. So you can reach from any place to the capital city of the state, and from that city you can reach to any city of your interest. So I feel the railway network of India is connected. That's a connected graph. So this is not just one place where graphs are used. Graphs can be used in many places. Even people may be involved in the graphs. That is, one such graph where people are involved is something which we all regularly use. I guess most of us use it like daily routine. Facebook. So Facebook network is a network which involves people. So as I said, the nodes are people, and edge is put if the 2 people are friends with each other. In that case, you will put an edge. So this is how the Facebook network is constructed. This is how the Facebook analyzes the data. So Facebook would store the details of your friendships and analyzes. It will give you recommendations, right? You may know this person. You may want to send a friend request to this person. Such recommendations, all these analysis are done. For that, the data has to be stored. So that for storing this kind of data of who is friends with whom, Facebook uses the graph data structure. That is, it denotes people by nodes, and edges are put if the people are friends with each other. And you can download the Facebook data set from this particular link. I had already downloaded, so I will not be downloading again. So the thing that you have to download is, there is a text file called Facebook combined. So basically they have different versions, I guess. The description is also available in the link. You can read through it. And the thing is, they had collected the data at various time intervals, the various geographical locations, and they had combined everything into a single text file. That is what we have it as Facebook combined.txt. Just download that particular thing. And one more thing that I want to tell is, graph is something, as I had shown you. If you would see, this is a pictorial representation of a graph. We have nodes and edges. This diagrammatical representation is easier on our minds, but how do we store this in a computer? We cannot feed in this figure and ask the computer to understand this. We need to store it in some specialized format. There are some formats by which you can store the graph data. There are many formats actually, but I will be discussing just one format that would be used in our Facebook data, that is how we get our Facebook data. I'm just going to discuss that format. Let us see. See, the format is called edge list representation. So just consider a sample graph. There are nodes 1, 2, 3, 4, and this is how the edges are present. There is an edge between 1 to 2, there is an edge between 2 and 3, there is an edge between 3 and 4. So you just, as I had said, 1, 2, 2, 3, 3, 4. 1 space 2, 2 space 3, 3 space 4. This is how you store it. This is what you call as an edge list. Edge list is one of the representations for graph. There are many other representations. You can look it up as to what are the other representations. There are some advantages and disadvantages associated with each representations. You can take a look at it as an advanced material in graphs.